We're actually going to start, I want you to flip over on the blank side, and we are going to come up with the law of cosines. There's just not room on the front. So we're going to redraw that little triangle that's on the front that looks like this. Let's see what that is. A, B, C. That makes this little a, this little b, this little c. Okay? So remember, we're applying trig to triangles that are not right triangles, and we can come up with our laws, okay, which are formulas, rules, whatever, using stuff that we already know how to do. So we're going to take this triangle that's not a right triangle, and I'm going to draw in the height. Height is always perpendicular to the base, much like we did with the law of sines, but we're going to label a couple extra things here. When we do that, we get a new point right here that we didn't bother to label on the other one, but it's going to be point B because we want to talk about this one. And I'm going to label this little section, or the segment AD, as X. If the whole segment is, the length is C and this part is X, that means this part has to be C minus X. Make sense? Okay, so we're going to look at both little right triangles that we just created. We're going to start by looking at triangle ADC and set up a couple of things. So triangle ADC. So the first thing is, in this little right triangle right here, I have all three sides labeled, so I can set up Pythagorean Theorem. Pythagorean Theorem is very easy. Leg squared plus leg squared equals hypotenuse squared. But I'm going to put the hypotenuse squared first instead. So b squared equals x squared plus h squared. Okay, make sense? You learned Pythagorean Theorem in like 6th grade, I think. All right, so then I'm going to look at this angle right here, and since we're coming up with the law of cosines, I'm going to take the cosine of angle A. So the cosine of A, that is adjacent over hypotenuse, so that's going to be x over b. And then I'm going to solve for x, so I'm going to multiply both sides by b, and I'll get b times the cosine of A equals x. So then I'm going to pause there, come back and use this stuff in just a second. We're going to look at the other right triangle, triangle DBC. I'm also going to set up Pythagorean Theorem with this one. So again, I've got leg squared plus leg squared equals hypotenuse squared, but I'm going to put the hypotenuse on the left-hand side. So I get a squared equals, then this side would be c minus x squared plus h squared. So we're doing all this because we need to come up with a rule that only uses the a, b's, and c's, and not the x and the h in there, because that's not information you would necessarily have about the triangle. Okay, so I've got this Pythagorean Theorem. I'm going to go ahead and expand this. It would not be c squared minus x squared. This would be a squared equals, you get a trinomial with this, it would be c squared minus 2cx plus x squared, and then that plus h squared. Okay. So my goal is to get rid of the x's and the h's, right? So I can do some substitution. I can substitute this x. I know right from right here that x is b times the cosine of a. So instead of x right there in my pink equation, I can put b times the cosine of a. So I'm going to go ahead and start rewriting from this. I've got a squared equals c squared minus 2 times c. And instead of x, I'm substituting this, b times the cosine of a. Then I also need to get rid of this x squared plus h squared. Well, I know what x squared plus h squared is also. X squared plus h squared is b squared. So instead of x squared plus h squared, I can substitute in a positive b squared. So now I have an equation that only uses a, b's, and c's. It came from Pythagorean Theorem and basic right triangle trig. Okay? And remember, when I show you things like this, you don't have to recreate this. But it's important for you to see where things are coming from so that you know it's not somebody just sitting around deciding, oh, I think I'll make up this equation, then it'll work. Or things wouldn't work if that was the case. It's coming from something, and you could, develop it. We could write it, and I'm actually going to rearrange some things here to make it in the right order. And so it would look like this. A squared equals, then I'm going to move the b squared to the front. B squared plus c squared minus 2bc times the cosine of angle A. So there's your law of cosines. There's actually 6 versions of the law of cosines, okay? You really only need one, which is this one. We'll write down 3 of them. We'll talk about what the other 3 are. But I want you to know that because, you may see a formula chart that has all 6 of them on there, or maybe just 2 of the versions or whatever. And really, you can do everything you need to do with this one right here. They're just different forms of this with things moved around. So let's go back. So flip it over. Let's talk about the law of cosines. So it can be used to find side and angle measures, just like law of sines could. But this is when we have side, angle, side, and side, side, side situations. If you're doing things correctly, it's impossible to use the wrong one. It's impossible to use law of cosines when you have to use law of sines, because it's not set up that way. If you look at number 1 here, if I wanted to use the law of sines, it's just a proportion, right? So I can say the sine of 127 over x equals the sine of, well, I would need one of these angles, and I don't have it, and I don't have the information to find it, so I can't use it, right? So you just won't be able to use the wrong one. All right, so we had a squared equals b squared plus c squared minus 2bc times the cosine of a. So what you need to get from these, because like on number 1, it's not labeled at all. There's no a's, b's, and c's. And even though 3 is triangle ABC, it could be PQR. Like the letters could be anything. So it's how this stuff is arranged that's important. Whatever the side length is that's on the outside has to correspond to the angle that's being used in here. So when we write these, you need to think about like what it means and not just that it's A, B, and C. So I could write this with b squared out here. So this is a side squared. It's equal to the other 2 sides squared and added together. So it'd be a squared plus c squared minus 2. And then you multiply these 2 sides together. So this will be 2 times a times c, and then times the cosine of angle b, because it has to correspond to that side. Right? So you need to understand the relationship in the formula. So you go ahead then and write out the c squared form of this. And that's what you should get. So all 3 forms are looked at just to make you understand. It doesn't matter which one you're doing. It works for all the sides, so it doesn't matter what they're called or anything else. We'll talk about what the other 3 look like here in just a minute. All right, but let's use this to do number 1. So it says to find each side length, so I'm looking for x. All right, well, x is across from 127, right? So x is going to go on the outside. It's a side length. I've got x squared. That's equal to, then I add the other 2 sides squared and added together. So 16 squared plus 28 squared minus 2. And then I multiply those 2 numbers together. 16 times 28 times the cosine of the angle across from x, which is 127. Now, I don't care about x squared. I want x. So I'm going to take the square root of both sides. And the square root of this is what's equal to x. And so you can type all that in the calculator all at once, hit your square root button, and type it all in. Square root's in the close to the top left, next to the fraction button. So I got 39.739. Make sure you get that number so that you know you're typing things in the right way, because I've had some people that are, you know, struggling a bit with it, and that's okay. We just want to make sure we get it figured out. And we have units on there, so you got to make sure you got your units. Inches, yeah. All right. Any questions about that? We good? All right. So on number 3, we've got triangle ABC. So we need to draw and label it. A, B, C. Angle C is 88 degrees. AC is 22 feet. BC is 11.5 feet. We're looking for the length of AB, so I'll call that X. See if you can get this set up and solve for X. All right, so did you get 24.466 feet? All right, now, did this question ask me for X? No, what did it ask me for? AB. So you got to make sure you're answering the question that's being asked. It's fine that we used X instead of AB in the work, but in the end, nobody asked you for X, right? Any questions at all? Okay, so that's finding a missing side length with the law of cosines. Now, finding a missing angle is where the other version of the formula could come in, and it's basically solved for the angle. But again, I don't think it's necessary. I think the more formulas you know and you see, the more you have an opportunity to get things confused. So if you just have something that works for everything, use that thing, all right? And don't let me forget at the end, I want to talk about the law of sines, because somebody had a very good question this morning, and I want to make sure and go over that, but I don't want to do it in the middle of the notes because I already forgot at the beginning. So just remind me at the end, because I want to tell you something about that. Okay. So with this, in the law of cosines, I have 3 sides. So this is like a side, side, side situation. This is not like the ambiguous case of the law of sines. If you get an angle, that's the angle you get. So remember that the angle in the law of cosines is related to the side length that's across from it. So when I set up my equation, I have some side outside squared, and so that's going to have to be 10. So I'm going to have 10 squared equals, then the other 2 squared and added together, so 11 squared plus 13 squared minus 2 times those 2 multiplied together, 11 times 13 times the cosine of the angle across from 10, which is x. Now in this example, we're going to write down more steps than we are in number 6, and then that you would absolutely have to. I just don't want to lose anybody in the process, so I want to make sure you understand what's happening here. I'm not actually squaring anything yet. I'm going to do it all at once in the end, let the calculator do it all for me. But I need to get this cosine of x by itself. So the first thing I'm going to do is subtract these 2 over to the other side. So I'm going to get 10 squared minus 11 squared minus 13 squared equals negative 2 times 11 times 13 times the cosine of x. Okay? Still trying to get cosine of x by itself. So all of this right here is being multiplied by the cosine of x, so I'm going to divide it to the other side. So I have 10 squared minus 11 squared minus 13 squared divided by negative 2 times 11 times 13, and that's equal to the cosine of x. Now, I don't care about the cosine of x. I want x. So what do I have to do? Inverse it. So x is equal to the cosine inverse of that whole fraction, 10 squared minus 11 squared minus 13 squared, all over negative 2 times 11 times 13. And even though I'm quite confident you at least know what 10 squared is, it's better really just let the calculator do everything so you don't have a brain fart about an easy number. Mm-hmm.
This is that first one. 100, 121, and 169.
Mm-hmm. You got it. All right. So when you type all that in, and go ahead and type it in, don't just wait for me to write it because we want to make sure we're pushing the right buttons. You should get 48.369 degrees. We all good? Did we get that? Are we still pushing? I need to give you a second. Okay. And I think the calculator doesn't mind if you don't close the big parentheses at the end, but if you don't close the little parentheses in the fractions, it's not real happy about things. So, of course, you don't even have to put the parentheses in the denominator. You can use the multiplication sign, but.
Yeah, but like when I did the cosine one, it wants you to close that.
Oh yeah, absolutely. Yeah. Yeah.
But yeah, the big one doesn't.
Yeah, the big one doesn't, but in the little ones in the fraction, yeah. So you probably learned that pretty quick because you're getting tired of getting errors. Okay, so let's look at number 6. There's no questions here? All right, so we have triangle RST. RS is 9, ST is 14, and RT is 6. We are looking for the measure of angle R. So I want you to just set up this equation right here for it and stop. So just set up the equation and stop, because I'm going to show you how you can do it much shorter. Basically what you would kind of have to write to show work, but what you can skip, that sort of thing. So check yourself with that. And tell me, why does 14 have to be outside? Because it's across from the angle that I'm looking for. Exactly. So make sure that you have that. Then the rest should kind of jive there. All right. They correspond. Yeah, basically they correspond or relate to each other. Okay, so I'm going to take this 14 squared. I'm going to subtract 6 squared, subtract 9 squared. So I've taken care of that, but then I also need to divide by that, so I can just do this all in one step. I was just afraid I'd lose people if I did it all in one step the first time. And that's equal to the cosine of theta. And that's really all you have to write, because now you should know, if you know I have to do the inverse, you don't necessarily have to write the inverse step as long as you find the inverse and you actually find the angle. So go ahead and find the angle there. I would suggest doing cosine inverse in the calculator first so that you can do it in one step. But if you don't, like if you typed in that fraction, then you could do the cosine inverse of the answer and use the answer button. That's fine too. There's different ways, different orders you could do things in. You just kind of want to learn to simplify it for yourself. And hopefully in the end, you get, okay, I'll wait. That's what I got, 137.011. Okay, did this question ask me for theta? Good. Ask me for the measure of angle R, so I need to make sure I say that is the measure of angle R, not just some random angle that I'm talking about. And I'm done. That's what the M means, yes. All right. Any questions at all? You did take geometry, right? Yeah. Okay. All right. Yeah. No. That was like in August of that year. You can't use that excuse. All right. So let's talk about law of sines real quick. So the law of sines we know is the sine of A over little a equals the sine of B over little b, which is equals the sine of C over little c, right? But apparently in Delta Math, I don't always look at every single one of their explanations, and they're not wrong. But when they, I guess, explain a sine, and I don't know if they do it on every single one of them. I don't know how consistent they are. But they show the formula as this. A over the sine of A equals B over the sine of B. And you should hopefully know enough about ratio and proportion to know that these are the exact same thing. As long as you flip the whole thing over, you're fine. And if you ever need to check yourself on that, if I cross multiply, I'm doing A times the sine of B. Well, that'd be A times the sine of B, B times the sine of A, B times the sine of A. So I have the same outcome. So really either one of them, and it's possible, I guess, even on a formula chart, you may see it this way instead of this way. It just depends on who wrote it and who thinks their way is better, but it's the same thing either way. So I don't care as long as you know it's a proportion and you get them related correctly, you're good. Okay? We good? Yeah. Yeah, I don't care. Yeah. All right, good. Any other questions? Awesome.